Hi everyone, in this video I am going to discuss about the dependency inversion principle, that is the part of the solid principle. So what is the single responsibility principle, open close principle, list substitution principle, interface aggregation principle and dependency inversion principle. So we will see the summary of these four principles, right, and in detail we will discuss about the dependency inversion principle in this video. So what is the single responsibility principle? By picture we can see that this knife have the multiple feature, right, but single responsibility principle say the class should have only one region to change, meaning that the class should have only one job. The class should not have multiple job or multiple method that doing the different job. All the method that should be related to the one job. It should not have a class should not have like doing the printing, saving the data, right, and doing the validation and doing a lot of other things, right. So this is the single responsibility principle. We'll come to the open close principle. The object and entity should be open for extension but closed for modification. But it should be open for extension. So in the picture you can see it, right? Because when you do the modification in the object, right, we have to test the entire thing, even the existing things, right, because it could be impact. So we can do the extension so that we can extend the feature through interface, right, and then dependency will be less, right, on the existing system, so that we need to test less. Now let's talk about the list substitution principle, right. So this principle states that if S is the type of T, right, then the object of the T should be replaceable with the object of the S. Suppose S is the subtype of the T. So S is the child of the T class. Okay, S is the class, and this is the subtype of the T class. So other way, if I explain, so S is the child and T is the parent, right? Then object of the T, right, object of the parent should be replaceable with the object of the S. So object of the parent should be replaceable of the object of the S. Right? Now next is the interface segregation principle. So client should never force to implement an interface that does not use. Okay, our client should not be forced to depend on the method they don't use it. So suppose we have a interface, right, and that have the 10 method, and I want to use that interface. I want to inherit that interface in my classes, right? But my classes need only 2 or 3 method of that interface. But when I will inherit the interface in my class, all the 10 method of the interface I need to implement in my class, right? Even though I need only 2 or 3 method that is relevant for me in my class. But we need to implement all other right, 7 method also of the interface in my class. So that is saying, that is what this point is saying. The client should never be forced to implement the interface that does not use. Okay. So here we are forcing to the client class, right, to implement all the 7 method of the interface that is not required, but even though we need to implement in our class, right. So even simple word we can say that we should have the small interface, right, so that we can inherit into our class where whichever the interface is required, right, instead of having the fat interface with multiple right method, we should have the minimum method, right, in interface, and that we can implement, we can inherit into our class, right. So we will not force the class to implement those method of the interface that is not really required. So in the picture you can see that, right. So here the single, just consider this wire, one wire is like a single one interface. Okay, and wherever this is the client, just consider, so if the client need, they can plug in any of the interface, right, whichever they relevant to that, right. But in this case, what is there, the client have to plug in, just consider this is the interface and this is the client, right, class. So when I'm inheriting the interface into the client, we have to give all the definition of these method, right. These are the method, just consider these are the method. So even though for me these 2 method are not required, but still I need to implement these 2 method also in my class, right. Let's move to the dependency inversion principle, right. So here high level module should not depend on the low level module, both should depend on the abstraction. Okay, so abstraction is what we talk about interface or abstract class. Okay, so high level module should not depend on the low level module. Okay, so we will take one example also to understand it. And second point also in this dependency inversion principle, abstraction should not depend on the detail, but detail should depend on the abstraction. So let's see that. So what is the high level module? We need to understand here. So high level module which provide the complex logic, okay, should be easily reusable and unaffected by the changes in the low level module, which provide utility feature, right. To achieve that, you need to introduce an abstraction that decouple the high level and low level module from each other. Let's take one example and try to understand it. Suppose this is the calculator class, okay, and here we have, this is the abstract class, right. So this is the I interface, this is the abstraction, okay, and what we are doing here, calculator is the high level module. This is the I calculator is the interface, and the below add calculator operation, subtract calculator operation, these four, right, is the low level module. So what our principles say that the high level module should not depend on the low level module. So calculator is the high level module, right? Should not depend on the low level module like add calculator operator, subtract calculator operator, right? Multiply calculator operator and divide calculator operator. So it should depend on the high level module should depend on the abstraction, right? So this is the abstraction part. So abstraction could be interface or abstract class, right? Or high level module calculator is depend on the now abstraction, right? It's not directly calculator class, it depend on the add calculator operation. That is the low level module. So that is what we are saying in this definition. Okay. So high level module in the dependency inversion principle, abstraction should not depend on the detail, right? Detail should depend on the abstraction. So if you see that, so these two are the detail, right? The calculator and these are the right classes are detailed class. Okay. So abstraction should not depend on the detail. So here this is the abstraction, right? This is not depend on these details. These are the classes: add calculator operator, right? Subtract calculator operator, or divide and multiply calculator operator. Abstract depend on the right. Abstraction should not depend on the detail, right? So here abstraction is not high calculator operation is not depend on the either calculator class or this add calculator operation class. Okay. So if you see that in traditional architecture, high level module depend on the low level module, right? And if you think in terms of the application with the presentation layer, the application layer, business layer, and data layer, right? We'll see through the diagram. So here the presentation layer is depend on the application layer, and application layer is depend on the business, right? And business depend on the data access. So presentation is the high level module, right? And that depend on the application layer. Again, the application is the high level module for the business, right? So this dependency is there. So if you change like this, right? If you create the interface for the application interface, business interface, and data access interface, and remove the dependency, right? So in that way, we can achieve the dependency inversion principle. So here the abstraction should not be depend on the detail, rather than detail should depend on the abstraction. So now detail is our presentation layer, application and business data access level. These layers are depend on the our abstraction, right? So abstraction is like application interface, business interface. So our detail module are depend on the abstraction. This is all about the dependency inversion principle.